Hello, welcome to the second video on verifying trig identities. I want to do the same problem I did before. Let's see if I remember it. And I do. Nice. So I want to do the same problem I did before, but I want to do it a different way. Just converting everything into sines and cosines. So again, just as a really quick review, we're verifying trigonometric identities. We want to make sure that the left-hand side is exactly equivalent to the right-hand side. So if we're going to put everything in terms of sines and cosines, obviously the left-hand side isn't where we want to start, right? We have 1 plus cosine theta over cosine theta, so we probably want to start with the right-hand side here, right? So let's go ahead and jump right into that. So we have tangent squared over secant theta minus 1. So tangent squared, you remember that's just sine over tangent sine over cosine, so tangent squared is sine squared over cosine squared. And secant, that's just 1 over cosine, right? Minus 1. So now this looks really messy, and we might be thinking, you know, why are we doing this? But remember that if we want to combine these guys, what do we have to get? That's right, you're probably shouting it out the computer. We have to get a common denominator, right? So here, if I multiply top and bottom of this 1 by cosine theta over cosine theta. Remember, I'm just multiplying by 1 here. Then I'd have cosine theta over cosine theta. And now I better move down here before I go off. So I have sine squared over cosine squared. Over, and now I can write this as 1 minus cosine theta over cosine theta, right? So now they have the same denominator. And let's do a little review really quickly. So remember that if you have some number a divided by b, which is divided by c over d, we keep our numerator the same, and we multiply by the reciprocal of this denominator. So let's go ahead and give that a try. So remember I said we keep our numerator the same. We multiply by our reciprocal of the denominator. And now, well, first let's just multiply straight across, right? I don't want to jump too many steps here. But hopefully you can see I have a cosine theta here divided by cosine squared. So this cosine's going to cancel, and yeah, that's fine. And then I'm going to be left with sine squared over cosine theta 1 minus cosine theta. And we need to know our Pythagorean identity, right? So that sine squared plus cosine squared is 1, right? So that means that sine squared is equal to 1 minus cosine squared. And if you watched the previous video, then you know that we have to remember our difference of squares, right? So I'll just put that here. So our difference of squares is that a plus b times a minus b is equal to a squared minus b squared. So here we have the a squared minus the b squared. So we can write this as 1 minus cosine theta times 1 plus cosine theta. So let's make that substitution. Sine squared, which is equal to 1 minus cosine squared, is equal to 1 minus cosine theta times 1 plus cosine theta. And now look at it, and do you see anything that's going to cancel? And of course you do, right? These are going to cancel. And I'm left with, I'm just going to write it down here, 1 plus cosine theta over cosine theta. And so this is our left-hand side. And we've shown that they're equivalent. So it's the same problem, but we did it in a completely different way. And so I hope that helped out a little bit. Thanks, guys.